All right, in problem 8a, we're asked to find the volume of the sphere of radius a using spherical coordinates. Okay, so we already know the answer is 4/3 pi a cubed, because that's just the familiar formula for the volume of a sphere. But let's see about setting this up with a triple integral in spherical coordinates. So here I have sphere of radius a centered at the origin. And so to think about letting, say, the radial distance rho vary first, we're going to let rho vary from, well, 0 when we're at the center of the ball out to a distance of rho equals a, which is just simply the radius of the ball, right? So rho will vary from 0 to a. Then we're going to have to let the angle phi vary from 0 to pi, so North Pole to South Pole. And then, since we're finding the volume of the entire ball, we're going to have to make one full trip around for theta. So theta is going to have to vary from 0 to 2 pi. All right, so here, if I go ahead and call the solid ball, let's call it, say, B, then we know that the volume of the ball is equal to the triple integral of just dv over the ball. And so now to set this up as an iterated integral in spherical coordinates, well, we're going to have our dv, and in spherical, this is our rho squared sine phi, and then we're going to have our d rho d phi d theta. So here I'll put in the rho squared sine phi, and then for rho, we're letting that vary from 0 to a. And then for theta, phi next, not theta. For phi, we're going to let that vary from 0 to pi. And then lastly, we're going to let theta vary from 0 to 2 pi. Okay. So now let's go ahead and compute. And notice here we have a product for our integrand, and this depends only on rho, this depends only on phi. So we can split all of this up as, well, the integral from 0 to 2 pi d theta. Then we have the integral from 0 to pi of sine phi d phi. And then we have the integral from 0 to a of rho squared. Okay, cool. So now this theta integral is just going to be 2 pi. This integral is going to be minus cos phi as we let phi vary from 0 to pi. And then here we're going to get a rho cubed over 3. And we're letting rho vary from 0 to a. Alright, so then if I plug in pi, I'll get 1. And then if I plug in 0, I'm going to get a negative 1, but it's being subtracted. So I'm actually going to get a 2 there, a 1 minus a negative 1. And then here I'm going to get an a cubed over 3. Plugging 0 in, I'm going to get a 0. So let's get a cubed over 3. And voila, there's your 4 pi a cubed over 3 as it should be. Alright, cool. In the next video, we'll do another volume calculation in part B.